All right, in this video, we're going to go over the equation of a plane in 3D. Before we get started, if this video is helpful to you at all, please leave a like. And if you would like to see anything else in future videos, please leave a comment. Let's get into it. So the equation of a plane in 3D relies on two components. One of them is the normal vector, right? And the other one is a point on the plane that we're describing. We only need those two things. When we have those two things, then we can fill out the rest of the equation. Now we're going to call the normal vector n. We're going to call the point on the plane p naught. N has three components. We're going to call them A, B, and C. And p naught has three components: x naught, y naught, and z naught. Okay, so these components for n, because n is a vector, are just the x, y, and z components. And for the point also has x, y, and z components because they both exist in three-dimensional space. All right, so now let's get into using this to write the equation for the plane. So the equation for the plane comes out to the first component of the vector multiplied by x minus x naught, and you'll see a bit of a pattern here, plus the second component of the vector, b, multiplied by y minus y naught, and you can guess what the last one is going to be, and that is the third component of the vector multiplied by z minus z naught. And all that equals 0. All right, so that is your vector equation for a plane in 3D. Now, let's actually put this into practice and use this equation. Okay, so let's say that you're given that the normal vector is equal to 3, -2, 5, and a point on the plane, p naught, is equal to 8, 3, 7. All right, so let's fill out this equation then. So this is our A value right here, right? This is our B value right here. This is our C value right here. This is our X naught value right here, our Y naught value right here, and our Z naught value right here. Okay, all that should be pretty clear, but let's go ahead and fill out this equation. 3 times x minus 8 plus -2 times y minus 3 plus 5 times z minus 7 equals 0. Now, will we leave this equation in this form? No, of course not. We would simplify, right? So let's go ahead and do that. 3x minus 24 minus 2y plus 6 plus 5z minus 35 equals 0. And then we can go ahead and pull all of the constants to the other side. 3x minus 2y plus 5z equals what? 24 plus 6, which is 18, or -18, minus 35, so that's 43, I think. So you'd end up with positive 43 over on this side. Okay, now can I divide anything out or simplify further? No. So this is my final answer right here. Okay, great. So say that instead of given a normal vector and another point, you're given 3 points in space, right? You should still be able to figure out what a plane is for 3 points. So say that you're given P1 equals 4, 8, 10, P2 equals 1, 2, 3, and let's say P3 equals 4, 2, 1. All right. So, well, we need two components. We need a point, and we could pick any one of these, right? Let's just pick this one, just for fun. Let's pick P2, right? So P2 is going to be our P naught, right? Let's say P naught equals 1, 2, 3. Great. Now, what is our normal vector? No idea. Let's figure that out. So one way of computing a normal vector is if we have two vectors on a plane, then we can, if we have two vectors in space, then we can take the cross product of those two vectors, and that will give us a vector that is perpendicular to both of those vectors, right? And if we remember what a normal vector is, right? If we have some plane in space, then a normal vector is just the vector that's perpendicular to that plane. It points up straight off that plane, right? So what this is saying is that if I have two vectors, say I have vector A and I have vector B, and both of those vectors are on the plane, right? They're on this plane. Then if I take the cross product of these two vectors, right? A cross B, right? Then that will give me my normal vector, right? Because the cross product of two vectors is always perpendicular to both of them. And since both of these vectors lie on this plane, then their cross product will be perpendicular to the plane and therefore will be the normal of that plane. All right, so we need A and B. But we don't have A and B. How can we find two vectors here, though? So we need A and we need B. So we're given 3 points that lie on this plane. And we need two vectors. Well, a vector is just an arrow that connects 2 points, right? So we can draw out these vectors, right? And now we have two vectors that lie on the plane. Say that this is P1, P2, and P3, just for example, right? Okay, so say that I want this vector A and I want this vector to be B. A would be P1 minus P2, right? The vector between any 2 points is the point of the head minus the point of the tail. So for A, we're going to do P1 minus P2. And for B, we're going to do P3 minus P2. Okay. And I just chose these vectors arbitrarily, right? I could very well have chosen a vector that goes from P1 to P3, and another vector that went from P1 to P2, or a vector that went from P3 to P2 over here, right? It doesn't matter which ones you choose. You just have to come up with two vectors that are both on the plane. All right. So let's solve for this. A is going to be P1 minus P2, and each of those, so the first component is going to be 4 minus 4, which is 0. Second is going to be 8 minus 2, which is going to be 6, right? And then 10 minus, oh, wait, no, I'm subtracting the wrong vectors. So 4 minus 1, 3, 8 minus 2, 6, and 10 minus 3, which is 7. P3 minus P2 is 4 minus 1 is 3, 2 minus 2 is 0, and 1 minus 3 is negative 2. All right. So let's work on taking the cross product between A and B. And we know that A cross B is going to be what gives us N, right? This is important. A cross B gives us N. So we worked out the cross product, and now we have this. And this would be our normal vector. You can go ahead and put that up here. So now we have our normal vector, and we have a point. So we can get rid of the rest of this, and, oh, not all that. Yes, all that. You can get rid, no. We can get rid of the rest of this, and instead, we want to focus on this equation up here, right? And let's bring that down here and work based off of that equation now. So the equation for a line. Now what are A, B, and C? A, B, and C are the components of the vector, right? And then X naught, Y naught, and Z naught are these right here. Let's go ahead and substitute everything in. All right, so we have negative 12 x minus 1 plus 27 y minus 2 minus 18 z minus 3 is all equal to 0. And then we can take all of that and simplify it out like we did with the other one, and that would give us our solution in the most simplified form. But I'm not going to work through that. I trust that you can do that. All right, so what if, for example, we weren't given 3 points? What if we were given a vector that's on the plane and we were given a point that's on the plane? Well, you would know how to work with that, right? Yeah, but, well, you're given a line that's on the plane, right? Say that you're given a line that's on the plane, and you're given a point that's on the plane. Okay, so you're given the equation for this line, right? F of x, or f of xy, or something like that. So you're given the function for this line. I'll just call this line L. And you're given this point. How would you go about solving that? Well, you could just pick 2 points along the line, and now you have 3 points, right? You have P1, P2, and P3. And now you can solve for that. How would you pick 2 points along the line? Easy. You just plug in some arbitrary value into the equation for the line and get out some coordinates for some point on the line. Then you have 2 points on the line, and then you have 1 point in space. And now we can make 2 vectors, take the cross product, and then that'll give us the normal. And pick one of our points to be P naught, and then we can write the equation for the plane. All right, I hope that this made sense, and I hope that the examples helped out some. If there's anything else that you would like to see, please leave a comment, and don't forget to leave a like if this was helpful. All right, have a good day.